All right, hello everyone. Today we're going to be talking about parallel and perpendicular lines and specifically the slopes of these lines and how their slopes are related. We're eventually going to be writing equations for these lines as well. This is a review lesson, so this is something that's typically covered in Algebra 1. I know if you had my class last year, we definitely talked about this, so this should be review for most of you. So let's go ahead and get started. Parallel lines, obviously we've been working with these for a while now in this chapter. They are lines that never cross, and in order for lines to be parallel, their slopes would have to be exactly the same. So just to show you what I'm talking about here, if these lines are actually parallel, that means that the rise over run would have to be the same for both of these lines. If it wasn't the same, then the lines would end up intersecting each other. So parallel lines have to have the same exact slope. So that's what we're going to put right here. Parallel lines will always have the same slope. Now, perpendicular lines, these are not going to have the same slope. They're actually going to have something called opposite reciprocal slopes. Opposite reciprocal slopes. And we will talk about what that means in just a second. So, in order to be perpendicular, the slopes have to be completely opposite. So as you can see here in this picture, one of these lines has a positive slope. See the lines going up? And the other one has a negative slope. So that is one thing that has to be true. It has to be completely opposite signs. So if one of the slopes is positive, the other one has to be negative. And they also have to be reciprocals. So here's a reminder of how that works if you don't remember what the word reciprocal means. So here's a couple examples of opposite reciprocals. Let's say we have a slope of 2 over 3. The opposite reciprocal of that would be negative 3 over 2. So it's going to be the opposite sign, so positive, negative, and then the fraction just flips upside down like that. So 2/3 and negative 3 over 2, that would be an example of opposite reciprocals. Another example, let me give you another example here. What if we have a slope of just positive 4, okay? Now that's not a fraction, but if you think of it as a fraction, it would have a 1 on the bottom, right? So in order to be an opposite reciprocal, it would be negative 1 over 4. So these would be considered opposite reciprocals because 4 over 1, if you flip that upside down, you would have 1 over 4, and then we would just make it negative. If you have a slope that's already negative, something like, negative 5 over 2, then the opposite reciprocal would be 2 over 5, positive 2 over 5. So we flip it upside down and we change the sign. The last one that I want to show you, and I'm running out of room here, one more opposite reciprocal would be something like this. Let's say we have the number 0. Now 0 is an interesting number because if you put a 1 under a 0, you actually can't flip this upside down. If you tried to flip it upside down, it would be 1 over 0, and that does not exist because you cannot divide a number by 0. So the opposite reciprocal of 0 is actually called undefined. It's a type of slope that you may or may not remember from Algebra 1. So there's a slope of 0. A slope of 0 is going to be just a horizontal line, and then a slope of undefined would be a vertical line. And as you can see, these are definitely going to be perpendicular to each other. So 0 and undefined, that's also considered opposite reciprocal. So let's show an example of how we're going to use this information. So in our first example here, we're just going to be determining whether the lines below are parallel, perpendicular, or maybe they're neither one. So all we have to do here is just find the slopes for each of these lines. So let's start with this first line here. So if you remember from our review yesterday, to find slope, we're just going to be subtracting the y values. So it's y2 minus y1 over x2 minus x1. So let's go ahead and do that. Now you can really subtract in whatever order you want as long as you're consistent both times. So you can start with the second y value and subtract the first one, or you could do it backwards, but you just have to do it both consistent on the top and bottom. So let's go ahead and start. I'm going to start with my y values. I have 2 and 0. So I would do 2 minus 0 over negative 2 minus 2. And then we'll just simplify. So 2 minus 0 is 2. Negative 2 minus 2 is negative 4. And then always make sure you're reducing your fractions. So that reduces down to negative 1/2. So the slope of that first line is negative 1/2. And then we're going to go ahead and find the slope of the second line. Same process. So we're going to do our y values, 4 minus negative 2, 4 minus negative 2. This is a double negative, right? Anytime you have this double negative, that's going to turn into a positive. So I'm going to write that as 4 plus 2. And then it's going to be over 4 minus 1. So this turns into 6 on the top and 3 on the bottom. And if you simplify that, that equals 2. So it's positive 2. And then you just have to compare the slopes. So these are definitely not the same, but they are opposite reciprocals, because if you flip 2 upside down, remember there's a 1 on the bottom, right? So if you flip it upside down, it would turn into 1 over 2, and it is negative and this one's positive. So since these are opposite reciprocals, that means the lines are perpendicular. Now you can write the word perpendicular like this, or you can use the symbol for perpendicular, which is the upside down T. So either one of these would be okay. Okay, so that's one example of how we're going to use this. We're just going to find slopes and then determine if the lines are parallel or perpendicular. Okay, so here's a couple more examples. We're going to do the same thing. We will find the slopes of each line, and then we will determine whether they are parallel, perpendicular, or neither one. So here we go, starting with line 1. Y values would be negative 2 and 1. So I'm going to go negative 2 minus 1 over negative 7 and then negative 3. So we have negative 7 take away negative 3. Just be careful with those double negatives. So this is going to turn into a plus. So we have negative 3 on the top, and then negative 7 plus 3, that's negative 4. Now 3 over 4 does not simplify, but we can get rid of those negatives because 2 negatives equals a positive. So we have 3 over 4. That's our first slope for line 1. Okay, now we're going to do line 2. So for line 2, we have 4 minus negative 1 over 8 minus 2. So once again, it turns into a plus on the top. So the 4 plus 1 is 5, 8 minus 2 is 6. And if you look at these two slopes, these are not related in any way. So they're not the same. They're also not opposite reciprocals. So we would go ahead and say that these are neither one. They're not parallel. They're not perpendicular either. All right, and then our last example here, same thing. We're going to subtract the y values to start our slope for line 1. So 9 minus 5 over, and then we would have negative 8 minus 10. And if we simplify that, 9 minus 5 is 4. Negative 8 minus 10 is negative 18. And then you want to make sure you always reduce your fractions. So if you simplify that, that reduces into negative 2 over 9. So the slope of line 1 is negative 2 over 9. And then let's go ahead and do line 2. So line 2, we have negative 6 and negative 4. So negative 6 minus negative 4 over 11 minus 2. And then this turns into a plus on top. Negative 6 plus 4 is negative 2. And then 11 minus 2 is 9. So this line also has a slope of negative 2 over 9. And as you can see, these are exactly the same. So since they're the same, that means that the lines are parallel. All right, and then another example of how we would use slopes. Sometimes instead of giving ordered pairs, you might just see a picture right here. So let's go ahead and take a look at what we have. Now you can kind of tell which lines look parallel just by how they're drawn, but we're going to go ahead and calculate this exactly. So it says determine which of the following lines are parallel and which are perpendicular. So if we look at the picture, there's a couple different ways you could do this. You could do it the exact same way we were doing the other ones. So they give you the ordered pairs here. So you could use slope formula. You could just do y2 minus y1 over x2 minus x1. You could calculate the slope of all of these lines, or you could do slope just by counting. So for example, let's start with this blue line here. We'll start with line A. So line A, I'm just going to write that over here. Line A. If you find the slope of that line, you can just count it out since we have a picture. So if you go from this dot to this dot, it is going up 1 and over 3. You can just count out the rise over run. So the slope of line A would be 1 over 3. Okay, and so that's how I'm going to be doing these. You could also use slope formula if you'd rather do that. So you can do the exact same thing you did up here, but I'm just going to be counting them out. So let's move on. I'm going to go ahead and do this red line. So we'll do line B. Okay, so line B, if you look at the slope here, I'm going to use these two dots. It's going up 1 over 2. So the slope of line B is 1 over 2. And then line C, I'm going to do the green line next. Line C, if you use these two dots here, it's going up 1 over 2 again. Okay, so we know for sure that these are parallel, right? Because these are the same slope. And then finally we have the purple line, so that diagonal line, this line D right here. I'm going to do that one right here. Now this line is actually going down. So the slope of this line is going to be negative. It's going down 2 and over 1. Down 2 over 1. So the slope would be negative 2 over 1, or you could just call that negative 2. Okay, so now we're going to compare all of our slopes. So the question was, determine which lines are parallel, which lines are perpendicular. Well, we know which ones are parallel. Line B and C are parallel because they have the same slope. So we'll say line B and C are parallel. You can write it out in words. You could say line B and C are parallel like this. Or another way that you could write that, this might be a little bit shorter, you could just say line B is parallel to line C. You can use the parallel symbol. Okay, so there we go. Those are parallel. And then finally, we'll say which ones are perpendicular. Line D is perpendicular to both of these because negative 2 is an opposite reciprocal of 1 over 2. So these are complete opposites. So you can say line D is perpendicular, I'm using the symbol there, is perpendicular to B and C. There we go. Okay, so now we're going to talk about how to do this with equations, and it's pretty simple. Again, you're just going to be comparing the slopes. So this says, using the linear equations, determine whether the lines are parallel, perpendicular, or neither. So as long as your equations are in slope-intercept form, this is really simple. So remember, slope-intercept form is y equals mx plus b. So as long as it looks like that, you can easily identify what that slope is. The slope would be m. So here we go. This first one, these are both in slope-intercept form. So the slope of this one is 5. The slope of this one is also 5. So because they have the same exact slope, we would say that these lines are parallel. So that's all we're doing here. Now, sometimes they will not be in slope-intercept form. I'm actually going to skip around a little bit. I'm going to do the one right below the one we just did. So as you can see, these equations are not in slope-intercept form. So you're just going to have to rearrange them and put them in slope-intercept form. This is something that we reviewed before yesterday, and it's something we did in Algebra 1. So this is, let's go ahead and fix this. We're going to be solving for y. So you want to start by moving the x to the other side. So we would subtract x. That's technically a 1x. So we're going to subtract 1x from both sides like this. And then we have 2y equals negative 1x. I typically put that first because that's what slope-intercept form looks like. And then plus 2. And then we just divide everything by 2. And we're going to rewrite it in slope-intercept. So it'd be y equals, now if your slope, so negative 1 divided by 2, we're just going to leave that as a fraction. So that would be negative 1/2 x. And then 2 divided by 2 is 1. So we could put plus 1. So there's our first line, which means our first line has a slope of negative 1/2. And then we're just going to go ahead and do the second line, same thing here. So we will subtract 6x from both sides. So we have negative 3y equals negative 6x plus 21. And then we're going to divide everything by negative 3. And then here we go. We have y equals negative 6 divided by negative 3. That's positive 2. And then 21 divided by negative 3 is negative 7. So here's our second line, and this one has a slope of positive 2. So now we just have to compare these. So these are not parallel because they're not the same, but they are perpendicular because these are opposite reciprocals. So these would be perpendicular. Okay, and then I'm going to go ahead and do the one right below that. I'm actually going to skip this half for now, just for the sake of time. You are more than welcome to try those. If you're working ahead, feel free to go ahead and try those. I'm going to skip those for now, just so we can get through the rest of these notes. I'm going to do this example over here. Okay, so for this one, now these equations are a little bit different. It just says y equals -7, and then this one says x equals 2. So these lines are special cases. We talked about these before. We talked about them in Algebra 1. This one is a horizontal line. So if you imagine this on a graph, it would be the line that crosses the y-axis at -7. So if you go down here, like pretend this is -7, it would be that line right there. So this line, it has a slope of 0 because it's horizontal. Now this line, it doesn't have a y in the equation at all. So in this situation, the slope of this would actually be undefined because this is a vertical line. So this is the line that crosses the x-axis at +2. So it would look something like this. Now these will always be perpendicular to each other. So if you have a horizontal line and a vertical line, those are definitely going to make a right angle in the middle. So we're just going to go ahead and say that these are perpendicular. So anytime you have a horizontal line and a vertical line together, they're always going to be perpendicular. Okay, so again, for the sake of time, I'm going to skip these examples. If you want to try them on your own, I will be posting the filled in version of my notes on my website later, so you can always check to see if you did those right. But we're going to go ahead and move on to the next page. All right, and the final thing we're going to learn how to do today is writing equations for parallel and perpendicular lines. So once again, this is something that we did in Algebra 1 last year, so hopefully this is review for you. But we're going to be taking a line that already has an equation. So here we go. It says we have a line right here, y equals 2x minus 3. And what we're going to be doing is making another line. So we want to write an equation for a different line that passes through this point and it's parallel to this line. So I'm going to show you how to do that in a second, but I kind of want to give you a visual of what we're actually trying to do here. So let's pretend, now you don't have to write this down, but let's pretend we have a graph, okay? And this is the line that we're working with, so 2x minus 3, that would have a y-intercept of -3, and then it would go up 2 over 1. Up 2 over 1. This is just a very rough picture of what this line would look like. So if we have this line right here, and then we also have the point that they gave us. So they gave us the point -1, +1. So imagine that point on the graph, -1, +1. That would be, I don't know, somewhere about right here. Okay, so what they're asking us to do is to make an equation for a line that would pass through this point, but it also has to be parallel to this line. So it's something that would look kind of like this, right? So we're looking for the equation of this red line. We know the equation of the blue line. The blue line was y equals 2x minus 3. We want to know what is the equation of the red line? Y equals what, right? Now we know what the slope should be. We know the slope should be 2. It has to be 2 because in order for the lines to be parallel to each other, they have to have the same slope, right? So what we're trying to figure out is that y-intercept. So I will show you, now you don't need a graph to do this. I'm just showing you the graph to give you a visual here. You can do this just using some algebra. So step 1, you just have to figure out what your slope should be. Now we already know what the slope should be. In order for the lines to be parallel, we want the slope to be the same exact thing. So if the first slope is 2, then our new slope has to be 2. So there we go. Step 1's all done. Now step 2, there's a couple different ways to do this next part. So I'm gonna show you both methods here. I'm gonna show you the first method here, and then there's an alternate method below. But one thing that you could do is you can actually use slope-intercept form, and you can plug in your slope and the point that they're giving you. So they're giving us this one, right? We want it to go through that point right there, -1, +1. So if we use -1 as the x value and +1 as the y value, and then remember our slope is 2, you're going to take each of these numbers here and you're going to put them into slope-intercept. So for example, the y value is 1, so that's going to go here for y, 1 equals. The slope is 2, so I'm going to put that for m, 2. And then in parentheses, I'm going to put my x value. My x value is -1, so that's going to go here. Now the b We don't have anything for b, so I'm just going to put plus b. That's actually what we're trying to find. And then you are left with this little equation, and this is really quick to solve here. You can multiply these, that's -2, bring down your plus b, bring down your 1, and then you could just add the 2. And we just figured out what b is. The b is the y-intercept. So 1 plus 2 is 3, so b equals 3. And then once you have your b, you can go ahead and make your equation. So the equation would look something like this. We know the slope is 2, so it would be y equals 2x, and then the y-intercept would be the one we just found. So since it says 3, we're just going to put plus 3. And there we go. That's the equation of the new line. And that kind of makes sense. If you go back to that picture that I drew up here, it does look like, if you look at that red line, it looks like that y-intercept would be right around 3, right? So here's +3. That looks accurate. Okay, so this is how you can do it. You would just figure out what your slope should be and then plug it into slope-intercept form, and then you can write your new equation. Now there is another way to do this. Some of you might remember a formula called point slope formula, and I'm going to show this method. Now you don't have to do this. If you don't want to remember this other formula, you don't have to do this. You could always do it the way that I showed up here, but I'm still going to show this because some people like to do this more. So here we go. First of all, our slope again was 2, right? So we have our slope. Now here's how you use point slope form. So it's a totally different formula. It looks like this. It's y minus y1 equals the slope times x minus x1. So what we're going to do is we're going to take the point that they gave us, which was -1 and +1. And you're going to plug in -1 for the x1 over here, and then the +1 for the y1. And then for your m, you're just going to use that slope of 2. So here's what the setup would look like. It would be y minus 1. So again, I just put that 1 right here next to the y, equals our slope, which is 2, times x minus -1. Now, since we have this double negative here, so again, this -1, it just came from our x value. Since we have this double negative, I'm going to change that to a plus. And then what you can do now is you can just simplify this equation, and we can turn this into slope-intercept. So you could distribute the 2 here. That would be 2x plus 2. And then over here you would have y minus 1. And then you can just add the 1 to both sides. And we got y equals 2x plus 3. There we go. So that's the other method. You can use either one. So you can use the point slope form and just plug it in, or you could use slope intercept. But make sure if you're using slope intercept, once you get that intercept, you have to put it back into the equation like this. Okay, so that's how we write equations for parallel lines. And then on the next page, now we're going to do some more equations. So on this page, we're also going to be looking at some perpendicular lines, and we'll see a variety of examples. If you look at that first example, that one is already a little bit different than the ones we just did. So it is saying parallel again. However, the line that they give you, so here's the line that they give you, it is not in slope-intercept form. So the first thing that you're going to have to do is put it in slope-intercept form. So let's go ahead and take care of that. So we want to rearrange this so that the y is by itself, because we want to be able to see what this slope is. So here we go. We're going to take away the 3x from both sides. So we have -4y equals -3x plus 12. And then we would divide both sides by -4. And then we would have y equals, now this does not divide, but we can get rid of those negatives because it's double negative. It's going to equal a positive 3 over 4x. And then 12 divided by -4 is -3. So this is the equation of the first line, okay? And the reason why we did that is because we needed the slope. The slope here is 3 over 4. So that is the slope that we're going to be using. Now, we also want it to pass through this point. So it's got to go through -8 to +2. So there's a couple ways we can do this. I'm going to use the slope-intercept way like this. So it's y equals mx plus b. And I'm just going to plug in these 3 numbers. So I'm going to put my slope for m. I'm going to put -8 for x. and then I'm going to put the positive 2 for y. So we're just going to plug all of these in. So it's going to look like this. 2 equals 3/4 times -8 plus b. And then now we're going to go ahead and solve for b. So we're going to do 3/4 times -8. Now, you do have to know how to do a fraction multiplied by a whole number. You can do it in your calculator if you need to. You could put a 1 on the bottom of this 8 if you want. I think that's how I'll do it. So 3 times -8, that's -24. And then 4 times 1 is 4. And if you divide those, that's -6. So 3/4 of -8, that's -6. And I'm going to bring down the 2, bring down the plus b, and then we can add the 6 to both sides. So we have 8 equals b. So that's our y-intercept. And then once you have the y-intercept, you just have to put it back into an equation. So your final equation would be y equals, slope has to be 3/4 because it's parallel, so 3/4 x, and then your y-intercept is 8, so plus 8. There we go. Okay, so now we need to do one that's perpendicular. So this is a little bit different. So here we go. Next example says, write an equation that is perpendicular to this one, and it has to pass through this point. Okay, so with perpendicular, the only difference here is that we are actually not going to be using 3/4 as our slope. We want something that would be perpendicular to that. So if you want it to be perpendicular, the new slope has to be completely opposite. Remember from the first page, we want to flip this upside down and make it negative. So the new slope is -4/3. So that's what we want to use. We don't want to use 3/4. We want to use -4/3. So here we go. Other than that, we're going to do it exactly the same. So we're still going to use this point that they gave us, and we're going to plug it into slope-intercept. So y equals mx plus b. I'm going to start plugging in all the numbers. So y is -3, so that's going to go here. Our slope is -4/3, and then the x was +3. So there's your setup, and then we can go ahead and multiply this out. So we're going to do -4/3 times 3. You can multiply that however you want, but that would just equal -4. So -4/3 times 3 is -4. And then we would add the b, bring down the -3 over here, and then we can add 4 to both sides. -3 plus 4 is 1, so our y-intercept is 1. And then remember that last step is to just take this piece and put them together into an equation. So it would be y equals -4/3 x. Make sure you don't accidentally use 3/4, right? We don't want to use 3/4. So it's -4/3 x and then plus 1, because that's your y-intercept. Okay, we have a few more examples here, but for the most part, they're done exactly the same. So let's go ahead and take a look at the next one. The next one is another perpendicular line. So let's look at what they gave us here. So they give us y equals x plus 6. So now the slope of this, we do have it. It just doesn't look like it's there. If there's no number there, remember that that's actually a 1. So the slope of this is 1. However, we do not want to use 1 as our new slope because we want a line that's perpendicular. So my new slope has to be the complete opposite of 1. So we're going to flip it upside down. Now 1 is an interesting number because if you flip it upside down, it's still going to be 1, right? So if you flip this, it's still just going to be 1/1. However, we do have to make it negative because that would be the opposite reciprocal. So our new slope is going to be -1 instead of +1. So I'm going to write that down right here. There's our new slope. And then we're going to go ahead and use the point. So the point is -7/10. And then we will plug that into our slope-intercept. All right, so here we go. The y is 10. So I'm going to put 10 equals, and then our new slope is -1 times our x value, which is -7, and then plus b. And then we'll go ahead and solve this out. So -1 times -7, that's +7. And then we would bring all of this down. Now we can take away the 7 from both sides. So b equals +3. And then we just have to put this together into our equation. So we would have y equals negative 1x, which is really the same thing as just negative x. That's actually how I'm going to write it. So it's negative x and then plus 3 because the y-intercept was 3. All right, there we go. This next example, it looks a little different because the equation that they give you is actually in point slope form. But that's okay. You actually don't need to manipulate this at all. You don't need to distribute. You don't really need to do anything to it because the only thing that we want from this equation would be the slope of the line. And we already have it. So since this is in point slope form, the slope of the line is actually this right here. So the slope is negative 1/3. So we don't really need any other information out of that except the slope. The slope is negative 1/3. Now we do want it to be perpendicular again. So I want to do the opposite reciprocal of negative 1/3. So we're going to flip this upside down. If we flip it upside down, it would be 3 over 1, which is the same thing as 3. However, we have to change the sign, right? So it's definitely going to be positive. We want it to be positive 3 over 1, which is positive 3, because opposite reciprocals would be flipped, and you also change the sign. So our new slope here is positive 3. All right, and then we're going to use our point. So it says negative 4/8. So let's go ahead and plug that into our slope-intercept. So we got y equals mx plus b. The y is 8. Our slope is 3. And then our x is negative 4. And then we'll go ahead and solve this for b. So this would turn into negative 12. And then we add the 12. So we get b equals 20. So there's your y-intercept. And then we can go ahead and make our equation. So y equals, make sure you're always using your new slope. Your new slope is 3, so it'd be 3x plus 20. All right, and then finally we have our last example. This one is a little different because it involves one of those special lines. So the easiest way to do this is to kind of picture it on a graph. So they want a line that is parallel to this one. Now this is a little different. The slope of this line is not 5, right? Because remember, slope is like mx. But this line does not have an x on it. So the slope is not 5. The slope doesn't look like it's there. The slope of this is actually 0, right? So because if you think about what this line is, this is actually a horizontal line. Another way to think of this is y equals 0x plus 5. So the slope is 0. And if you were to picture this on a graph, I'm going to draw a little graph here. That's the best way to do these. It would be the horizontal line that crosses the y-axis at 5. So something like this. So this is y equals 5. And what they're asking for here is a line that passes through 2, negative 6. But it has to be parallel. So the only way for it to be parallel is for it to also have a slope of 0, right? It has to have that slope of 0, which means it has to be horizontal again. So the quickest way to do this one is just to imagine what that would look like on a graph. If you go to 2, negative 6 on your graph, and just think about, where that would be, positive 2, negative 6, it'd be somewhere down here. So 2, negative 6. If you want a line that's parallel to that purple one, it would have to just be horizontal, right? And the equation of this line, it would just be y equals, and then it was just going to be whatever the y value is at this point. So the y value is negative 6. So the equation of this new line would have to be y equals negative 6. And we're done. We don't really have to do any other work. So if you are given a horizontal line or even a vertical line, sometimes the best thing to do is just draw a picture, and then you can see, okay, that line would be there. A parallel line would have to look like this, which means it's just going to be y equals negative 6, okay? And that is it for the notes. So you guys can go ahead and start your homework for today.